look over the chemical changes and how they are. Again, the chemical changes. I have for you, yes, this one, which is in changes in matter. We have physical and chemical, and you know that, which are the changes in the phases of matter. You know the changes of phases of matter? Yes. If we have, for example, solids, to change from the solid into liquid, okay, so in the solid, to change into liquid, we made like melting. So the process was melting and the method was heating, right? Okay. And for example, we can say that the change from the liquid into the solid is done by freezing. Yes, solidification. So here, freezing. So only here changes in the phase of matter, right? It's right. Okay, but the liquid, to change into gas, the process is evaporation and the method is by heating. And the gas, to change into liquid, the process is condensation and the method is cooling. And every time, to change from solid into liquid into gas, I'm getting hotter. I am adding thermal energy. But from changing from gas into liquid into solid, I'm getting colder. I'm removing thermal energy, right? Or I'm taking thermal energy from the material itself. It's only phase change in the phase of matter, change of the phase of the matter, but it's nothing else. So this is an example of the physical changes, right? Okay, but what about the chemical changes? Again, the chemical changes here, examples are, number one, rusting. Yeah, like iron oxide, which is already different from iron, because iron oxide is made or results by rusting of the iron, right? Excellent, it's rusting. And here, what is this? This is match. You know the match? It's burning of the matches. Yeah. And here, what is this? This is the fried egg. It's a cooking, example of cooking. And here, what is this? You know, it's like here, it's actually the antacids. You know the antacids? Which is, for example, the antacid sachets, the effervescent tablets. Like, you know, vitamin C? When we have common cold and we use vitamin C, for example, it's not antacid, sure, but it's a kind of effervescent tablet. It's orange in color and it's big in size, and when you have common cold, your dad bring you a big tablet of vitamin C effervescent, right? And we put it in water. You remember that? Did you take it before? Huh? Someone take that when we have a common cold? Did you take antacid or did you take vitamin C effervescent tablet? Yeah. Okay, don't worry. It's a medicine, okay? But actually it's a kind of tablet. Yeah, that's one. Yeah. Okay, so this one we put it in water, and what happened there? Effervescence. We call it in chemistry, we call it effervescence happen. What is the meaning of effervescence in chemistry? Effervescence means, yes, it's the getting out of gas. What gas? Carbon dioxide gas. Okay? So what is the meaning of effervescence? Like antacid tablets, like vitamin C tablet, and also we have some kinds of minerals like calcium. Calcium also could come in the form of effervescent tablets, and some sachets. You know hyperacidity, when people are suffering from hyperacidity, and they used to take like effervescent sachets to calm their hyperacidity. Yeah. So these they put in water and effervescence happen because of the getting out of gas. What gas actually? It's carbon dioxide gas. Carbon dioxide is not one of the constituents in the tablet itself, but because it's an example of, yeah, excellent, because it's an example of chemical reaction happened there, so there is rearrangement of the atoms of the material itself, and there is breaking down and formation of the bonds of the material itself, and so new gases could be formed, like carbon dioxide gas. So here, when there is formation of carbon dioxide gas upon effervescence, like in case of antacid tablets, we can consider it also as kind of chemical changes, right? And what is this? Sure, it's a kind of burning, but this is a big burn. Ash, smoke, and fumes, and a lot of gases. Carbon dioxide and also, yes, and also what? And also carbon monoxide gases. Okay, very nice. So these were like classification of the changes in matter, which could be physical changes at which the identity of the material is not changing, only the change in the phase of matter, like the change in the size, the shape, the volume, or the position. But here the chemical at which a new kind of matter is formed with different physical and chemical properties, like in case of rusting, like in case of burning and cooking and effervescence and acid tablets, and also fire. What is this? We have something called the copper. What? This is the copper tree, like the copper wires. You know the copper wires, which are inside the electric wires. Inside it, there is a copper wire. You know it? Yeah. This copper. Yes. This copper, if we put it in a certain chemical solution, it has some chemicals inside. There is a chemical reaction happening.